Hello everyone, this is Dr. Ali, and in this session we want to solve the knapsack problem using dynamic programming. If you remember, programming was a method that comes to cover that shortcoming of that recursion method. So in the actual Fibonacci sequence, we mentioned that there are lots of subtrees that we keep calling them, we keep calculating them, while we actually don't need to redo all of those recalculations that impose a lots of delay. And we saw that for that Fibonacci sequence, if we want to calculate a Fibonacci sequence of only 40 numbers, it will takes a lot of time. And even if we increase it to 100 or even 50, 60 of Fibonacci sequence, it takes like a long time. While when we convert it to the dynamic programming way to solving that Fibonacci sequence, it was a matter of seconds to give us the answer. And we facing the similar issue here that with this knapsack problem in the recursion format, we are doing the similar or the same actual computation over and over. Look at this line 5. And we are calling the knapsack the same function by space, weights, values, and n-1 parameters. But we're doing the same similar thing here in the line 7 and 8. So there is a high chance that this calculation is actually the same, and we're doing it, keep doing it again and again. So in order to bypass this, we need to have some space, have some let's say, a table to reserve or save all of those calculations that we have done so far. And if for further calculation, we check this table, if that, let's say, a calculation is there, we just use it and we don't need to recalculate anything. Okay, that was the intuition behind why we need to do dynamic programming. Imagine that we have 3 items and the weight and value for each one of item exists in this table. And then in dynamic programming for knapsack, we create a table which its rows are one more than the number of the items. So here we have 3 items, so we have 4 rows. And the columns of it is the one more than the number of the weight of the maximum weight of the knapsack. So in our case, in our example, the knapsack has 7 kilograms. So we have 8 columns from 0 to 7. And we have an initial condition and we have a recursive condition. There is this recursive, I already covered that in the previous part that we already covered, and I mentioned what are those basically the recursion part, that if we include it or exclude it, if and we find the maximum between excluded part and the included part, and plus the bk is the value of that item that we want to check to include it or exclude it. But here in this part, we actually want to include it. And this first condition is for the time for those scenarios that the weight of that item that we want to select actually has the more weight than the available weight in the knapsack. Basically, this condition is the same as this explanation that we said here. Okay. And what is this initial conditions here? Consider this b, capital B, as a function that returning the value of the value of a knapsack problem with I item, and the W is the weight of that maximum weight that the knapsack can accept, right? Here it says if B0W means that if there is no item, then what is the value? If there is no item that we pick from, so it means the value that exists in the knapsack is 0. So basically, all of these items are 0. Same as this column, all of these items are 0 as well. Why? Because basically, what are these saying? It says that W is 0. Why? It's assumed that, let's say we have a knapsack that doesn't have any space. So it doesn't matter then how many items we have. It's always 0, the value, because we cannot include anything in it. There is no space. So considering this explanation, we have this. This is for the start. This row and this column is 0. Then, whenever we want to find the value for these items here, any of these items, we follow this recursion rule that we have, right? For example, we want to see what is the value of this let's say this cell, right? It says that find the maximum between the cell above it. The cell above it actually is this item. K minus 1W is the cell above it. And BK, the value of BK and the value of K minus 1 and W minus WK. What is the W here? Is 1. What is the WK here? Is 1. 1 minus 1? 0. So it says go to this cell, whatever the value it has is 0. And this part is 0 plus BK. BK is the value of that item that we want to add. What is the value for this item? You look at here, this is value of item 1 is 3. So that's 3 plus 0. So maximum between 0 and 3 plus 0 is 0. It is 3. So that's why we put 3 here. And you can fill the rest like that. And let's say we want to fill this item here. Okay, how's this come? Again, we want to find the maximum between the cell above it, which is 3, and 4, which is the value for the item 2. This is 4. You see this 4 here. Plus the W min minus WK. W is 2. We are in the column 2. Minus WK. W for the second item is 2. 2 minus 2 is 0. So we look at this item. So 3, the maximum between 3 and 0 plus 4. And now when we calculate that, we calculate the rest as I explained already. And then we calculate the number, the last item in the this table tells us that what is the maximum amount of value that this problem can have, which is 11, right? And then if we want to then trace back to see what are those, which items actually included, we should compare this value, this is the maximum value, which is always in the bottom right corner, compare it with the one above it. If it is not equal, it means what? It means that the item, third item is already included, because there was no other way that this 7 turns to 11. It means that we added an item, and that item under exploration is 3. So this 3 item added. So then we good here. So we know that the item 3 is added. And then we want to check the second item. How's the second item? Is it added or didn't add it? So what we need to do, we know that the weight here is 7, correct? The weight for this column is 7. And we know that we added item 3. So we remove the item 3, the 7 minus the weight for item 3, to see what was the status of this table before adding item 3. So 7 minus 3 is 4. So the next, the previous status was here, right? 7 minus 3 is 4. So we were here at this cell that we added this actually the weight, and then we come to the this 7, the weight 7, right? And then so then we know that okay, item 2 is also included. But if the item then we check this item with the item above, so it's not same. Whenever these 2 items are not same, it means that item, previous item, is also included. So this 7, the weight for this column is 4. 4 minus the weight for this 2, the second item is 2. So 4 minus 2 is 2. So this is the status of the items, the table, before we added the second item. So we see that all the 3 items are added. Item 1, item 2, item 3. And maybe this is not a good example because right now all of these items are included. But if you see another table, maybe in the code section, I'll give you another example that the cells that above this, let's say this element, is the same value. if that's the case, it means that that item above this lower item is not included, because there is no change between the values. When the values are not changing, it means that okay, we didn't add it. So we keep going up till we reach to the first item that doesn't have the same value as the value that we want to investigate. So we will see another example that makes it more clear. But so far, if you have any comment or question, leave it down below and stay tuned for the next session. Have a great day, everyone.